Hi, I'm Bob Doyle, webcasting from my ITV studio in Cambridge, Massachusetts. I'm hoping to reach philosophers and scientists around the world to help solve some important problems in philosophy, in physics, in biology, and in psychology. I also hope to reach any of you out there wondering about the deepest nature of reality and our place in the universe. We live in the information age, but I find that very few philosophers or scientists understand the nature of information. Information is neither matter nor energy. It needs matter to be embodied in our brain, for example, and it needs energy to be communicated like this lecture coming to you over the internet. But matter and energy are conserved quantities. It may be hard to believe, but the total amount of matter and energy in the universe today is the same as it was at the beginning of the universe nearly 14 billion years ago. And if the stuff of the material world is just a fixed total amount, what can possibly explain all the evolutionary change that we see? I'll explain those changes as the information and order in the universe, which has been increasing since the beginning of time, despite the second law of thermodynamics, whose increasing entropy destroys order. Now, I will argue that change is simply the arrangement of those existing atoms and molecules into what I call information structures, like the galaxies, stars, and planets. But galaxies and stars are passive objects under the complete control of physical forces like gravity. Living things like you and I, however, are dynamic and growing information structures, and I'll show that we are under our own free control. I'll show that we are forms through which matter and energy continuously flow, and I'll show its information processing from the DNA in our cells to the thoughts in our minds that gives us that control. Information is the modern spirit, the ghost in the machine, the mind in our body, and it is our souls. When we die, it's our matter that remains, only our information, our form, perishes. I'll show that information philosophy can solve a number of mysterious aspects in quantum physics, like the two-slit experiment we've been discussing, the collapse of the wave function, and entanglement. This very strange idea that a cat can be simultaneously dead or alive, that one object can be in two places at the same time, or that information can travel faster than the speed of light, what Einstein called a spooky action at a distance. Okay, it's a Thursday, and today is our Metaphysics Day, and you'll see I've got my title for today's lecture up on the screen, and it is going to be on a very important, I'll call it the central problem in metaphysics, which to me is the existence, the question of the existence, the question of the status in the universe of pure ideas. This question has been asked for a long time. It goes back to the Neoplatonic philosopher Porphyry, who was a great student of Plato, and he argued that it was not at all clear what the Platonic reality, as Plato called it, could possibly be. After all, the physical world, the material world around us, we seem to be very substantial. Objects are substantial. Where is the thing that Plato thought was the, quote, real world? Today we speak about the real world, the objective reality around us, as Einstein called it, as just the material contents of the world, the furniture of the world, some philosophers call it, right? But Porphyry asked, where are the ideas? Now, we tend to think, well, they're in our minds, but we've had a couple of hundred years of questioning the reality of a mind as opposed to a brain. A brain is clearly a material object, and today the research that neuroscientists are doing is telling us the workings of these neurons and how they fire, how electrical, sort of semi-electrical signals in the form of ions traveling up and down, or the ionic potential traveling up and down a neuron, are able to communicate information. Somehow our basic thinking is an internal communication of ideas, although some might say, no, the electronic or electrical chemical electricity, chemical potential traveling around in our brain is nothing but a chemical process. Some scientists want to argue and say, aha, chemistry, well, that's totally reducible to physics. And physics, of course, is the fundamental explanatory tool that we use to understand the contents of the universe. As I open the lecture, what we have in the universe is a number of atoms, molecules, macromolecules built into living things, but all the way down the atoms are known to be made up of more elementary particles like the protons and neutrons in the nucleus of an atom, the electron going around the outside. And today we even reduce or discover that the proton, the neutron, the nuclear particles are made of smaller particles, the quarks, and various other energetic systems that moderate and glue together the quarks and other subnuclear particles. So with this picture going from the particles of matter all the way up to the galaxies, the stars, and the planets, and this planet that we're living on, it seems as if science wants to push us in the direction of an explanation that reduces us all to those material particles. And somehow many scientists and philosophers who have a strong science envy, physics envy, they'd like to be explaining everything, and they'd like to explain it in terms of particles and forces between the particles. They're happy with this view of a reduction to material events. I, however, would like to argue, and do argue, that there is another level, much like the original Platonic level of what Plato called his ideas. Now, Plato actually coined the term in Greek, ideia, which became our idea, and it came from the root to have seen. It's a past participle of a verb that means to see. It's id or wid or vid, which is the vid in video. Video that we're using today in my internet television studio here, sending you pictures of myself, has this root notion that to see, to have seen something, is to know it. And knowledge comes out of the concept of having seen things. So Plato has given us this different world, perhaps. Kant, 2,000 years later, will also talk about a material or phenomenal world in which Kant saw the physical laws as being totally effective, and we're completely controlled by them as phenomena, said Kant. But there was also for Kant a noumenal world above the phenomenal world, or at least outside space and time was one way moderns interpret this notion that came from Kant, that there's a realm in which other things are happening, maybe because normally the phenomenal world is the world of space and time, so it's hard to talk about them happening, but they have, in Kant's view, a kind of control over what goes on in the phenomenal world, although it's mysteriously said to be outside space and time. And there is, in this noumenal realm, the noumena, by the way, comes from a Greek word nous, which is more or less the concept of our mind again. So there's a mind level, a mind reality, and a material reality in the Kantian picture. That belief in a kind of mind is very strong in a large range of thought communities. For example, it could be the mind of God, all-knowing, but outside space and time. It could be the panpsychism view, which is very popular today among a lot of philosophers of mind, philosophers of consciousness, argue that there may be some kind of collective consciousness in which we all participate, and that's going on in the level, this mind level. Although some take it very particularly, and there's this psyche, or this mind, is said to be a property of all things, all the way down to the atoms, electrons, all participate in this mind. They make a very strong argument, which goes like this: how could the mind possibly emerge out of immaterial matter? Well, if you confront that argument and say, I agree, I mean, how can mind enter the universe from the material world that pre-existed the mind? Clearly, that would be some sort of miraculous event, makes no sense, and therefore they say mind must be coterminous, co-originating with the universe itself, and just a general property of the universe. That sounds like a very simple, but I find it a very simplistic argument, for the reason that when we get to living things, something wonderful happens. And the thing that happens is that instead of structures forming out of force, pulled together by forces, like the origin of the universe, when the quarks and electrons or whatever are the most primordial of all the tiniest particles, when they start to assemble into nuclei, and then that happens relatively early, and then hundreds of thousands of years go by before the universe can cool down to the order of 5,000 degrees, about the temperature of the surface of the sun. So if you're following me, in all directions in the universe, there's radiation that's just as hot as the current surface of the sun, and one can't see anything in any direction. But at that time, this 400,000 year point, 380,000 some say, the electrons suddenly can bind up with a neutron, proton, and form an atom. And at that time, the universe suddenly becomes transparent. One can see out to great distances. And since that time, 380,000 years after the origin, 13 point whatever, 7 billion years ago, suddenly the universe became transparent. It remains transparent to this day. When we look out now in the night sky, we not only see stars nearby in our galaxy, we not only see galaxies out to nearly 10 or 11 billion years ago, very close, not all the way, to the more or less the beginning of the universe, but in all directions, the very farthest thing that we can see, not literally see, but detect with microwave antennae, we see this glow in all directions, perfectly spherical. In all directions, there's a glow which is extremely cold, 3 degrees absolute. 3 degrees, we call it Kelvin. It's on this scale like the centigrade scale, but then 270 degrees, the zero that we think of as centigrade zero, there's this extremely cold glow in the sky, okay? But the universe became transparent then, and so the photons of light, which are now very long wavelengths, microwaves coming to us, are coming to us from a time when the universe was only 380,000 years old. Okay, I want to just home in on the origin of the mind, or the origin of where I would like to say we can identify the coming into the universe of a process which leads to the kind of conversation we are having now. Well, it's sort of a monologue because I have no idea how many people are listening to me today. The numbers on YouTube are growing, and Facebook as well, slight growth. YouTube, I'm seeing more and more viewers of my early lectures, but no sign that Facebook finds the old ones. I really need some technical help to learn how to manage my Facebook page and organize it into playlists, as they call it over on YouTube as well. Can't make my way through the Facebook interface just as yet. It isn't easy enough for me. But let me get home in here now. Until life forms on our planet, we have no evidence of anything going on that's anything like thinking. And so as I trace that backward in time and imagine a very early Earth and look for the origin of life, which is a wonderful project. I sit in occasionally on the initiative to study the origin of life here at Harvard. I can imagine a time when there were complicated molecules forming, because we already know there are atoms, they form into molecules. Even in interstellar space, we see chemical evidence of pre-biological, we call them macromolecules. No sign of life out there, despite our best efforts to search and listen carefully in all directions and so forth. But I can imagine at the earliest sign of something different happening, it would be when a complicated molecule happened accidentally, I assume, to duplicate itself. Now, there are some who say that duplication probably happened on some sort of hospitable substrate, like a surface of clay, where it would be easy for the molecule to stretch itself out, and maybe there would come to join it along it a duplicate of the molecule. We know the fundamental methodology of DNA is to split itself and then have another joined version of itself, because DNA is this double helix. And if we then made it simpler than the modern DNA, which is a wonderfully complicated basis for a machine, an information management machine, we go back, if we just have one molecule and another one forms up against it, and then another one forms up against that, and then we have more and more and more, and they're replicating themselves, information is now being replicated, duplicated. There's more of it. And this is what I've been focusing on as sort of the central issue in information philosophy. What was it that brought information into the chaotic, high entropy, disorderly universe? What brought information in the first place? Well, we know it's the universe expanded and gave room for things to form. But focusing again on early life on Earth, we would then say, here's information duplicating itself just by carbon copies, so to speak, and we're getting more and more of a certain molecule. Now we can imagine that the molecule duplication process might have had a mistake in it. Suppose, oops, it creates a different copy because it's missing something or added something new. That could go on, and now we have a process which will not just duplicate itself indefinitely, which means lots and lots more information, but it's all identical to the early one, so there's nothing interesting yet going on. And we can picture now that a new molecule might have a different capability, and it would go on to duplicate itself, and it would be superior to the original. We've got there the core of the idea of variation followed by natural selection, which tells us that that's the core idea of natural selection and Darwinian evolution. Now, if we imagine these duplicating systems get to the point where they ultimately have basically within them a template or a program to create the next one. Now we have not only information structures, as I call them, like the planets, stars, and galaxies, but I have a little information duplicating, replicating system which is using information to duplicate itself. And now I see information playing a role, an active role in the creation of additional things, which are proto-life. Then we come on up through all the other living things that grow all the possible species, and we see very clearly that already at a single cell, that cell has in it a program in the form of a DNA. There are arguments that long before DNA there was life based on RNA, a much simpler molecule, and so forth back in time. But nevertheless, from my information philosophy and information biology point of view, what we're seeing here is information involved in its own duplication, involved in its own creation of more life. And that I would like to distinguish such information structures, or creation of such information structures, as active. There's an active agency going on if you can impart the sense of an agency to the information which is in charge of the process by which new things come into being. Now it's a long leap, but we can, in my mind, leap all the way to my own mind and say, well, I have information in my mind, the immaterial part of my brain. Mind is that old analogy, the software in the brain hardware. So it's immaterial information, even though it's embodied. And that information is now actively in charge of what I'm doing with myself and with you. Those of you who are staying on listening here to this explanation, I think are actively reacting. Either you think this may be nonsense because you haven't, I don't think, read it anywhere. There's been a great controversy in the field of biology as to the exact role of an abstract notion of information. There are a group of biosemioticians. Semioticians study language, symbols, sign systems. And these semioticians who are trying to apply their work in biology and saying it looks clear to them that inside biological systems there are signals going around. That's more or less granted today. There's a kind of language here. There's certainly, as we know, the metaphor that the nucleotides A, G, C, and T in DNA are like letters in an alphabet that allows you to write sentences, so to speak, words and sentences which are sent around inside our cells and are used, for example, to send a message out of the nucleus when some important essential element that we need to metabolize or we need to carry energy around with our red blood cells. The things that a body needs to do requires the availability of the fundamental entities that do the work. So take a red blood cell for a moment. We have billions and billions of red blood cells, and quite strikingly, 200 million red blood cells in our bodies die every second. This is a phenomenal construction, maintenance, repair problem, because if we lose 200 million red blood cells, they have to be replenished. And inside each one of those red blood cells, there are 300 million, what's the word I'm looking for? Blanking my own kind of understanding of things. The complicated molecule, or actually a protein or an enzyme called hemoglobin. Globin, it's a sort of spherical structure made up of 4 alpha and beta type strands of protein, which fold around one another and trap in the center an iron atom, which is the heme, the energy carrying oxygen molecule, or just a single oxygen atom, I believe, is in the middle of each hemoglobin. And there are 300 million of these in just one red blood cell. So think about the task. We have to produce a fully new protein, initially forming out of long strings of polypeptide chains, they're called. They're long strings of amino acids which come out of a little factory called a ribosome. And we have to produce, that's the number of amino acids in hemoglobin is something like 300. So we have to have these 300 amino acids perfectly arranged, no mistakes allowed, so as they will fold themselves up into this little globular object that traps an iron atom in the center. That becomes our hemoglobin, which is our energy transport system from our lungs, where the oxygen is taken in and travels to all the parts of our body, providing that energy to our other cells, okay? So, just to give you the magnitude of what's going on in our bodies, we have 200 million red blood cells dying, many more in the time of my saying these sentences. In each one, 300 million hemoglobins. In each hemoglobin, 300 little amino acids needed to be assembled perfectly by a little copying machine that copies a message from the nucleus, from the DNA. The messenger RNA comes out with the message that contains the code of the sequence of the amino acids. And that happens every second. So we're multiplying 200 million times 300 million, which is like 60,000 quadrillion, times another 300. We're in the quintillions of events going on in our bodies every second. And so you can see how far away we are from my image of the original duplicating process of a molecule. But to me, the same thing is going on. What happens in a star, what happens in the galaxy is information structures form. But they're simply forming under the forces and pressure of some other process, some other physical process like gravity. Or at the beginning of the universe, the nucleons, protons, and neutrons are forming under a binding force of nuclear force. Those are not using information to do what they do. They're simply doing what they do because they are physical, purely physical processes. What's going on in biology is that there's some information that starts to play a role in the creation of the living things. And it's clearly evident as soon as we get even not just to a cell, but the individual organelles, the little structures inside the cells, the little ATP machine, which is involved in providing that energy. It's a wonderful distinction I'm trying to make between passive information structures and active information structures, for which information is involved and performing the providing the information to manage itself. That's my definition of life. If we can then imagine that information that's in charge of biology becomes a method by which we are retaining information somewhere in our brains and then using those thoughts in our mind to decide what we are going to do, I have now a model for an active agent where the information is the source of the possible things to do. In my model of free will, the first stage is always some possibilities are generated for us to act, take our next step, do the next thing, go this way instead of that way. If that's all done at an abstract, immaterial information level, we see why the philosophers through the ages always were looking for such a thing. It seems transparently obvious, perhaps to the man on the street, that we have minds that we think, and those thoughts lead to our actions. And the thoughts are not the actions, right? The thoughts are the possibilities. The actions are the actualities. There's a great triple of words that I would like to introduce today as we get into the existential status of ideas. We can distinguish possibilities, and each possibility in physics can have an associated probability, and that's the whole heart of quantum mechanics. But then all those possibilities, whenever an event happens, only one of those possibilities is realized, not in the Platonic sense, but in the everyday normal way of speaking sense, and it becomes actual. So we have this triple of possibilities with their probabilities, and then the actualities. And that would become a part of, it was a part of my free will book, which I will just kind of remind you that I hope you'll be trying to turn to the chapters of this book sometime when you want to go more deeply into my work. And those of you who like books, they're available in print, but you can also download PDFs from my website and read individual chapters. Now, in this case, the chapter I'm interested in, let me switch to my overhead camera for a moment. We'll come to metaphysics in another moment. In Free Will, chapter 8, I see, is called Actual, Possible, and Probable. And maybe I'll zoom in a little bit on this page and see what I have to say here. I point out that as a philosopher who was trained in physics, I think I can see why philosophers trained in logic may be uncomfortable with libertarian solutions to the problem of free will that involve indeterminism and uncertainty, ontological and objective chance. So we've been over that a little bit before, but I want to today to see if I can convince you that without chance, there can be no possibilities. And the way we'll do that is by looking at the work of Claude Shannon, who was the creator of the theory of communicating information over telephone wires and so forth. And he's given us expressions and the math that shows us why we need possibilities in order to have information. Mathematically, he's shown if there's only one possibility, then a message doesn't contain any new information. But if there are multiple possibilities, say 2 possibilities, then Shannon says there's the 1 bit of information will be transmitted over the wire when you decide between the 2. He then shows that if there are 4 possibilities, to distinguish which one, you have to generate 2 bits of information. The entire information age is built on this simple architecture that 1 bit gives you the information to choose between chocolate and vanilla or whatever. And if you need to choose between 4, you need more bits. The example I like to use a lot is the chessboard with 8 by 8 squares of black and white squares, 64 squares. In order to tell you where a piece is on that chessboard, you could say white king 4, because that's a way of talking about and giving that square a name. But if you don't know names for the squares, you would do something like saying, answer the question, is it in the top half of the board or the bottom half of the board? 1 pit says it's in the bottom half. Oh, you could say, is it at the right bottom or the left bottom? 2 bits. It's in the right bottom. If it's in the right bottom, is it in the upper right bottom or the lower right bottom? 1 more bit, and we're down to 16 possible squares left. When we answer 6 questions, is it here or there, splitting it evenly, 6 questions, it becomes an amount of information which is the 2, the fundamental bit choice, to the 6th power. Because we've asked 6 questions, each one gave us an answer to a 2-bit question, and 2 to the 6th power, 2 to the 3rd power is 8, and 2 to the 6th is 64. 64 squares. That is the core idea of reducing knowledge to the answers to questions. And if you make the questions binary questions, so there are only 2 options, you get 1 bit of information every time someone answers the question. But when we come back to what Shannon has now taught us, if the message has only 1 answer, and it can't be anything else, then no information is communicated. And same with our view of understanding of knowledge in the universe. When we try to digitize or make that information into single bits, yes or no, 1 or 0, on or off in the electrical model, the cell, the circuit element, the memory element is either on or off. We then see how all knowledge is now being cast into digital form, which is very, very wonderful. Because when I first saw a television screen, it was all analog. The signals were varying voltages, and they were susceptible to noise if the toaster was running, and electrical noise was just putting wavy images on our screen. Today, our screens are entirely digital. They're wonderful. They're perfect. either perfect or they disappear completely and turn up into blocks of noise and so forth, as you know. So we're all, I hope, getting more and more familiar with why we're in an information age and why we ought to understand at a more deep level what it is those bits of information are that allow us to create a picture on a computer screen for our animations or on a television screen for our communications. Okay, so this chapter, Actual, Possible, Probable, is something I think you might want to look at in my free will book. And here let's see, I'll just back up a sec with this and go here. My metaphysics book, the subject we have today, this central question about the ontological status of ideas, is discussed some in the chapter on possibility. But I'm afraid this is a bit too technical for us today because I'll just remind you that there's a lot of talk today about having possible worlds, many possible worlds. Physics is full of the idea of many worlds, of parallel universes, the multiverse. That was all discussed a great deal before there was any of this idea that there were possible worlds in science, because Leibniz, you'll all recall, is famous for defining the best of all possible worlds. Now, the best of all possible worlds became for Leibniz a deep philosophical question. It remains one today in metaphysics. Metaphysics has a lot to do with questions like this. Let me switch us to my website that discusses metaphysics. As you know, I have the Information Philosopher website, and let me just put this screen up here and come back to myself here. Here's my metaphysicist webpage. You'll see that it has down the left-hand side all of the thinkers that I've, you see them here. Let me turn myself around. This column can go up and down to the 200 philosophers and 100 scientists. And it also has the drop-down menus that correspond to my Information Philosopher website. So if I touch quantum here, it opens up all the quantum problems I'm discussing. If I press on free will, for example, those are the important questions I'm trying to answer under free will. And I want to stop, take a breath, and point out that there's a kind of a limit to the amount of explanatory power that I believe we have, and certainly I have, when I just try to talk to you about these enormously important, really, I hope, problems in philosophy and physics and biology and psychology. So this is my third book called Great Problems. Once again, it's available to you should you be a professor and teaching some of this material. You're not going to have to ask your students to buy that book, okay? It is on Amazon and it's available, but I have put all of the chapters, and more or less the chapters correspond to sections in the metaphysics website. For example, I have here a history of metaphysics, for example, starting with the pre-Socratics. Let's see if you can take a closer look at that. I would go here. And then Socrates and Plato, Stoics, Skeptics, the Scholastics, Middle Ages, Descartes, and then Leibniz. Now Leibniz, we just mentioned, was discussing the problem of is this the best of all possible worlds? And there were other scholars around his time who talked about other worlds as if maybe stars out there in the universe were home for other lives, other living systems. But anyway, possible worlds becomes a question. And the question for me, of course, is there another world different from but resident in the material world? And that's our question here. The idea of just questioning ideas, as Porphyry did when he said, what is, this was called Porphyry's fateful problem. Fateful because, let's see, I really want to put this one up here for us. What could Porphyry imagine could be the substantial nature, if there was one or not? What could be, where would these ideas of Plato's be? The perfect triangle, for example, the perfect horse, the notion that there was a perfection in this Platonic reality above the material reality, that those ideas of the things we see pre-exist the world itself. Plato's vision was that the real world, his real world, the ideal world, and it's exactly that great duality between idealism and materialism here, right? We've talked before about all the dualisms through the ages, all variations on the name ideal or material. We'll see them all, theories and experiments, for example, in physics. What is Porphyry worried about? How can an idea be somewhere? Well, they're in our minds, people said, but then we came to question the minds, and what is the mind anyway, and so forth. So, as I say, homing in on this page, the central problem that I see it is the status of these ideas. And one thing, sub-question is, how do they come to be? And what I've just been arguing is that in order for an idea to come to be, in our case by our thinking them up, we need novelty, and novelty demands chance or possibilities. If we don't have possibilities, then the total amount of everything is a constant in the universe, just like matter and energy. And there are many philosophers who've argued that the knowledge in the world, which for me is the information in the world, whether it's in the galaxies in the form of their shapes and the stars in the form of their material structures, is that information a constant, like the matter and energy? Many, many people think so. You can see why. It's really quite sort of hospitable for the notion that not only is the total knowledge in the universe a fixed amount, like the matter, or a constant, steady over time, it's a hospitable idea to the notion of a supreme intelligence, in whose mind all that information exists in the Platonic sense. And then the material world is a poor copy of the perfect world. You remember that Plato went on to say that when we artists, as artists, we draw pictures of this secondary imitation world, it becomes an imitation of an imitation, so that our artwork is at the lowest level. So that was tough on the artists from Plato's time. But anyway, I insist that we really need to bring matter into new forms, into new shapes, in order to have new information enter the world. Now, I say here, a materialist metaphysics, let me bring that up to your screen. A materialist metaphysics asks questions about the underlying substrate presumed to constitute all the objects in the universe. And let's see, what I'd like to do here is go to ifi.org up here. Give me just a moment. Okay, let's see what we have here. Switch to this screen. This is my blog again, and I want to encourage you to go here to get the introduction to my lecture should you want to watch it ahead of time. I try to post this at least the morning of my lecture, around 10 or 11 o'clock. And when it's posted, it has this little description, which I'm working with right now. And then as I work down chronologically backward in time, here's yesterday's lecture. And what I've done here is, I had a description yesterday, and this morning the YouTube Google's YouTube processed the lecture and allowed me to edit it with a title and this poster with the title, and the fact that this was a lecture in my Philosophers and Scientists series. This would have been Tuesday's lecture when we separated free will from moral responsibility. And again, I had an introduction of the kinds of separations we wanted and a diagram of the difference between free will on the one hand and moral responsibility on the other. And again, another lecture. And finally, we're back to our Monday lecture and so forth with a description. And I hope you'll find it, some of you, useful to take a look at this in advance, perhaps, when you're seriously trying to study what I'm doing. And let's see if I guess I want to show you that, separating from, I want to go home. Surprised I can't get back, here we are, to the central problem. Because what I wanted to do was, you remember, I like to be able to expand the text on the screen so you can read it a little more easily. And I'm getting around to being able to do this pretty well. Thanks for bearing with me. What I want to now point out is we had just a material metaphysics. It's the one that says that all we have is material objects in the universe. And I have here a quote from Jaegwon Kim, the professor emeritus at Brown, who basically says the bits of matter and their aggregates in space-time exhaust the contents of the world. This means that one would be embracing an ontology that posits entities other than material substances, that is, immaterial minds or souls outside physical space with immaterial, non-physical properties. Now, I'm back to getting this on the screen. I think I can do that right here. Here's my quote from Jaegwon Kim, who is one of the leading philosophers of mind. And I think I just bumped the mouse, which my selection of that text for you to read easily went away. And Jaegwon Kim in Philosophy of Mind is a little like, or close to in many respects, Dan Dennett, who we've been talking about these last couple of weeks, who denies the kind of libertarian free will that involves the genuine creation of new possibilities that I've been arguing for. In that Jaegwon Kim basically says there is nothing like anything outside the material world. He denies a Platonic realm of ideas and hopes to explain everything that we do in our walking, talking, acting, thinking, etc., as something coming up from below in the form of an explanation that reduces our brain to our neurons, reduces our neurons to our chemistry of the flow of ions and changes in the ionic potential and the firing of the neurons, and reduces those firings to the ions or atoms themselves, because he thinks chemistry reduces to physics and biology reduces to chemistry, and even psychology is now here nowhere to be seen. Again, my quote has disappeared. But he argues that we would be trying to think in terms of immaterial minds or souls. And I want to say yes, although for many years I certainly was one who thought that the question of a soul, especially, of course, a soul that exists past death, is a very questionable thing to think about, and most scientists don't pay much attention to that unless they're religious believers and want to believe in this idea that they continue on after death, so-called afterlife. But I am now going to try, and I am trying to argue that we do have something very much like what the ancient philosophers and some modern believers think of as an immaterial soul, an immaterial mind. It's just that it's not outside physical space. It is outside material space in the sense that it's embodied in material, so that our thoughts are embodied, that is to say, they're stored in our brain somewhere. But they are in fact not the brain hardware. They are instead the mind software. It's like the information in a computer, which in no way really is the electrical state of whether or not a memory bit is turned on or off. It still is the same memory bit. We then turn it on and off in order to have the computer contain information that we want it to have, and we can erase that and start all over again. Well, in a human mind, our experiences have been recorded, and they are there for us to retrieve, and I have a model on how it is that our experiences, our new experiences, are interpreted and are given meaning by triggering older experiences, and they play back in our mind, and that enables us to deal with the current situation based on our past experiences. The whole idea of learning in my information philosophy model is that our experiences get recorded along with whether or not we felt good about them at the time or bad about them, so that the emotional aspect of experience is stored away with our past experience. A terrible sort of proof or of argument for that model is so-called post-traumatic stress, which upon having a new experience, a loud noise, suddenly brings back horrific past experiences for war veterans who've been had these really terrible experiences, but those are recorded and played back in what I call the experience recorder and reproducer. So let's go back. I've gotten a bit away from the deep question of the existence of an idea, or technically the term is ontological, a word that comes from the early thinkers who said, do these things have being? You will maybe remember that Plato and his mentor, or an earlier philosopher that impressed him a great deal named Parmenides, argued that some things had being and other things come and go, change all the time. And the architect of that idea was Heraclitus, who said that everything's flowing, you can't step in the same river twice, there's no constancy here. But Heraclitus did say that there was a logos, an overall system that controlled the flow, controlled the change. And I think in Heraclitus we see the beginning of a scientist who's looking for the rules, the laws of nature, which govern the change that we see around us all the time. So I think I wanted to possibly look at this page. I think we've looked at this mostly. That was in the chapter in metaphysics, and I want to remind you that I do have a page in the Free Will book, chapter 8, which tries to talk about these three stages, if you like, between the existence of something actual and the pre-existence of ideas. And so I think we're ready to home in on the location that Porphyry asked about Plato's ideas. Where are Plato's ideas? And we can give one explanation, which is usually in texts that try to come up on this and say something serious about it. One view is that ideas, our ideas, only exist in our own minds. There are no ideas, say, in rocks. They have no psyche. They don't exist there because ideas are things that were experienced and learned and taught to human beings, and that the whole idea of Plato's ideas is very much a human thing, and only a human thing. We're exceptional. We have ideas. On the other hand, those who saw that some of the ideas in the early work of the Greeks who invented logic and much of mathematics, had a very strong feeling, shared by Plato, that the triangle, a circle, a perfect circle, surely has a kind of being about it. Because a perfect circle, like a truth in logic, arguably a truth, if it is true, is always true. Its truth is kind of eternal. And you remember that the early philosophers like to think of things like truth and goodness and beauty were all eternal properties. Well, it's questionable. Certainly taste suggests that beauty is depends a lot on one's society and so forth, and goodness has the same problem of moral relativism that we discussed recently when we tried to separate free will from whether or not the willed action was moral or not. Separate question. Free will is a scientific question. Moral responsibility is a cultural, social question. But now, this philosophical thought about things that have being was the topic in Aristotle's books, which got categorized as metaphysics. So we've come full circle to metaphysics as being the having this central question that when those things that have being outside of time because they're eternal, outside of space because they don't seem to be material, they seem to be abstract. And you're looking at the Information Philosopher, who argues that that abstractness is because they are nothing but forms. And forms is extremely close to the notion of the original words or thoughts connected by Plato to the ideas, like the circle, clearly some sort of perfect form. I would then like to argue that the forms are the information, and the information is what we see when we look at an information structure, and we see it has a form, beautiful spherical form in the case of the stars and so forth. And that is indeed, like Plato spoke, and perhaps Kant, a different realm in the sense that it is not material, it is immaterial. And so, besides the simple claim that the ideas exist in minds, which they do, I'm presenting them to you, and as humans we're able to take our ideas and put them into forms like books, like words, texts, structures, our buildings. Those are ideas that we've turned into material embodiments of ideas, but those are all forms when they are ideas. And so we can say, I think, that ideas exist in the universe by being embodied in structures that are carrying bits of information. And that's my solution to the great question, the central question of what is the status of ideas. They exist, but not as material, but as the arrangement of material, and they also exist as one of the most useful things we can do, is to have ideas and spread them around from one person to another. So let me say we should wind up this program, and I'll turn this music up a little bit. Some people say the music makes it hard to understand what I'm arguing about, but I like to put it at the beginning and then bookend it at the end of our talk. And I hope you will be back next week when we do another lecture from my book on metaphysics. People are writing to me asking questions, and it's kind of hard to respond to too many questions coming in. Some people tend to ask a similar kind of thing more than once, but the best I can do quickly is to refer you to sections in my books, my Great Problems book and the Free Will book, and up and coming will be my Einstein book, but I can also refer you to my website, informationphilosopher.com, to my metaphysicist.com, which is going to give us a lot of, I think a lot of these arguments, you'll find answers there. But I also hope to send you to my blog, which is here, and look there for what's going to be up and coming. And I think at this point I should say goodbye and hope to see you next time. Here's my email address as we sign off, and look forward to hearing you too, having you back tomorrow for